Okay, so this is my geometry project, and I'm going to do the volume, or not volume, the area of parallelograms first. And I'm also going to attach a link to each one of these things because it's kind of hard to draw and visualize. So on the link I'll have a visual representation of where the formula came from. Okay, so for parallelogram, this is not drawn to scale, but you'll see how it works on the video in the link I attach it to. But if you split this triangle off and you put it right here, so if you take this off and you put it right here, it creates another triangle, so it makes a perfect rectangle. And a rectangle's area formula is length times width as well, so that's why the parallelogram has the same area formula as a rectangle, and that's why a rectangle is a parallelogram. And I'll also, when I'm talking about prisms, I'll explain how the length times width formula, where it came from. So that is it for parallelograms, and I'll have my practice problem in a second. Okay, so now we have our real world example, and in the real world, people use this for finding the square footage, like the amount of tiles they need per square foot in a room that could be in the shape of a parallelogram, such as a rectangle, which is very common. So if you had a room in the shape of a rectangle, you would use the formula for the parallelogram, A equals length times width. And so let's say it was 8 and 7. This is not very realistic numbers, but okay. So it'd be 56 feet squared, and we'll say this is feet because that makes more sense. Okay, and so that's what you get.